Let's go ahead and try to graph one period of this function that has a secant involved, but there's a lot more going on than just that. Now, I will warn you that some of these don't work out super nice as far as some of our numbers aren't going to be nice, but we'll walk through the steps and make sure you understand by the end. So the first thing I want to do is relate together secant, very basic, secant of x is 1 over cosine of x, right? Based on reciprocal relationships, right? Reciprocal identities. So let's think about cosine. Cosine goes between 0 and 2 pi, as will secant. We're going to be careful about all of our, just breaking this down as far as our labels on the x-axis and our y-axis. All right, so from 0 to 2 pi, just kind of labeling all the important values in the middle. Typically, cosine goes between -1 and +1. And for cosine, what it's going to do is it's going to start here at the top, come down, bottom out here at -1, back to 0 at 3 pi over 2, and finish up here back at +1 for a y value. Now, for our secant graph, what ends up happening is wherever cosine worked out to be 0, we get a vertical asymptote. So you'll notice for our cosine graph, where it hits 0, vertical asymptote to go along with that for a secant's graph. Because what ends up happening is we flip upside down each one of these y values. So if you had a y value at 1, that's going to happen to be on both of these graphs. All right, -1 is going to be on both these graphs. Because if you take a -1 over 1 and you flip it upside down, you get 1 over -1, which works out to be the same thing. Where things go a little bit different, though, is if you say had a y value at 1/2 on the cosine graph, when you flip it upside down, you go 2 over 1, you get a value of 2 on our secant's graph. So what ends up happening is you get these kind of loops, is how I'll describe them. They're not exactly loops, but they kind of look like parabolas. All right, so what's in black on that graph is our secant graph. And then what's in blue, that's our cosine graph. All right, so one period typically goes from 0 to 2 pi, and it goes kind of up from 1 at the beginning, and then from -infinity to -1, kind of has that loop going at the bottom. And then we finish up with a loop starting at the top and ending up at +1. All right, so now that that's taken care of and we have our basic function kind of graph going on, let's talk about our different components. All right, where I want to think about this is our function is going to be split up to like a times secant. And what I'd like to see is b times x minus c on the inside, and then a plus d at the end. And we'll go through and talk about what each one of these letter values kind of contributes to the overall graph. So you may notice the first thing on ours is you don't see that factored form on the inside. So on ours, we have that -6 is going to correspond with our a at the beginning. But then what we want to do is we want to factor out and have 1x to the first power on the inside. So what we're going to do is factor out a 4 from each one of these terms. And this is a little bit tricky on the inside here, but we're going to get an x. And then in our case, it's going to be plus 1/2 on the inside. And then a -8 at the end. All right, so now that we've done that quick factoring, and if we redistributed this 4 that I wrote on the inside here, we should get those exact same 2 terms on the inside of our secant back. All right, so let's break this down into A and D contribute to vertical changes. All right, so first, let's think about our vertical changes. A has to do with values on the y-axis. So typically, if that was a 1 hanging out in front, it would go between -1 and +1. It would be like the values on our y-axis. But in our case, A is -6. So what that does is a couple of things. It says +6 and -6 are going to be our values we care about initially on our y-axis. All right, we would refer to this as being a stretch. All right, of our graph. Okay, the other thing is we have this negative out in front of the 6. That is going to be a vertical reflection. So now kind of the breakdown of our graph, instead of going up at the beginning, we got like 6 and -6, and just giving you kind of a rough look at what this is going to look like. Our vertical asymptotes haven't changed. But instead of going up at the beginning, we start at the bottom. It's been flipped upside down, remember, and it goes down at the beginning. Our middle loop kind of goes up, and then we finish at the bottom. All right, kind of looking like that. All right, that takes care of the y-axis labels are the 6 and -6 based on that stretch, and then that negative in front flipped everything upside down. Now, the other component that's going to affect us vertically is going to be that d is going to be -8. Because 8 has been subtracted from the entire function, what this is going to do is this is going to move everything down 8 units. Okay, so vertical movement, we've moved everything down 8 units. That's going to affect all of these values on our y-axis. All right, so we were at 6 and -6 as kind of our key values on the y-axis. Now we're going to subtract 8 from each of those. So when we do 6 minus 8, that's going to take us all the way down to -2 as our upper value. And -6 minus 8 is going to be -14 for kind of this other value on our y-axis that we care about. I told you these are kind of ugly. Just we're going to have to deal with it in this case. Those actually aren't as bad as what the rest of this is going to be. All right, next up, let's talk about, actually, let's write this out as horizontal. What's changed horizontally? All right, horizontally is going to be affected by those values inside the function. So inside of the secant, we have b is going to be 4. This has to do with the period of our graph. Okay, we can calculate the period of our graph as the original period divided by whatever b is. All right, so the original period for secant is typically 2 pi, right? Just like cosine, it goes from 0 to 2 pi before you move it around. But then you have to divide that by whatever b is. In our case, b was 4, so 2 pi divided by 4, or a little bit of simplifying down, that's pi over 2. All right, that means that from beginning to end, we're going to start at 0, and we're going to end at pi over 2 in this case, before we start repeating ourselves, right, during the first period. Now, we also want to get the other values, kind of the key values along the way. So one of those lies in the middle, which is half of pi over 2, which ends up being pi over 4. Not doing a great job of showing my work on this, but I just divided that by half. We also want these other two values. Halfway between 0 and pi over 4 for the middle is, again, you divide by 2 or multiply by 1/2, works out to be pi over 8. Then the final value works out to be 3 pi over 8. If you add together pi over 8 and pi over 4, we end up with that 3 pi over 8. Not the prettiest of values for our labels on our x-axis, but that's okay. All right, the last thing we have to take into account is our value for c. In our case, c is that plus 1/2 on the inside, actually works out to be a negative 1/2. What this is going to be is this is going to be a horizontal movement. Horizontal shift. We would describe this as a shift to the left of 1/2. All right, so kind of go with me on this. What I'm going to do is get our new labels to go along with the x-axis. If I start out with 0 and I subtract 1/2 to move to the left 1/2, that makes it at negative 1/2. These other ones are a little bit messy, so just go with me on these. If we need to, we can break this down further. But if we did pi over 2, kind of our ending value, pi over 2 minus 1/2, I'm going to label that as pi minus 1 all over 2. It's not going to be pretty, like I said. These other ones, just trust me on them. I'm just subtracting 1/2 from each one of these, working to get a common denominator along the way. Pi over 2 over 4, and 3 pi minus 4 all over 8. All right, a little bit of work, use your imagination, get back to basics on fractions and common denominators the whole way through. All right, now let's put this all together and try to get a nice graph. Remembering that we're going to bring along our vertical labels and these horizontal labels, as well as the fact that this has been flipped upside down to help us out. All right, so one period of this graph. Remember, everything's been shifted down significantly. So let's start out at -1/2. And then I'm just going to kind of label these as I go through so you get an idea of where everything's at. All right, actually, I'm going to move -1/2 over just a little bit because it works out that pi minus 4 all divided by 8 is also a negative value overall. So -1/2. And then we're going to get a vertical asymptote at pi minus 4 divided by 8. Kind of put in a vertical asymptote here. All right, next value is pi minus 2 over 4. All right, at that next one, we're going to get 3 pi minus 4 all divided by 8, and that's going to correspond with a vertical asymptote again. And then we're going to finish up on that last label. And I know these aren't maybe as evenly spaced as what we'd like, but pi minus 1 over 2. So now we have all of the x-axis labels in there. We also need all the y-axis labels. So remember, that was -2 and -14. So maybe not perfect as far as these look, but let's say -2 is right here. And I'm going -14 is this value down here. All right, recall this has been flipped upside down. So much like this graph, we're going to start at the lower label, right? In our case, that's going to be at -14. And then the first x-axis label, which is going to be -1/2. All right, so -1/2, -14, right about here. And then it's going to go down when we approach that vertical asymptote. Our next one, remember, it's the same look as this graph up here, circled in blue. It's going to be at pi minus 2 all divided by 4, so like the third label in, and the y-axis label of -2 for the lowest value. And then it's going to go up this way to kind of be a loop going on there. And then we're going to wrap up -14 for our y-axis label. And then our last x-axis label, which is going to be this pi minus 1 all divided by 2. Kind of sketch in as we approach the vertical asymptote from the right-hand side, it's going to go down. All right, so that is our graph, and a pretty good one because we've labeled all of the x-axis and y-axis. We've got the basic shape going on. Now, I'm not positive that this one crosses at the origin, right? I didn't go and get any extra x-intercepts going along. I basically focused on x-axis labels for vertical asymptotes and these key points, either the highest value or lowest value, and our y-axis labels along the way. But if we get all those in the right place, I think we're going to get a pretty good graph, just like this one is, of our function. A little bit of work to get here. It would have been nicer if we had nice integer values instead of these weird fractions going on, but that's how it is sometimes. So I hope this helps out. Good luck as you're working on graphing some difficult looking functions.